Hello students, welcome back to our channel Maths Infinity. I am Dr. Koshish Sarkar. We already know that JEE Advanced for this year has already been conducted. Today we will discuss some problem from paper 1. Okay, first look at the problem 1. The problem is given is that fx is a continuously differentiable function on this interval 0 to infinity such that f of 1 is equal to 2, and if satisfies this condition that limit t tends to x, t to the power 10 minus fx minus x to the power 10 f of t by t to the power 9 minus x to the power 9 is equal to 1, then what will be fx? So students, we will solve this problem. We can solve this problem in various techniques. First, we will solve this in a very simple way. First, look at this thing. If we take limit t tends to x, then both numerator and denominator is 0. So this becomes a 0 by 0 form, that is undefined form. And from very basic theory of calculus from class 11, we can say that in the case of 0 by 0 form, we can use L'Hospital rule. So what is L'Hospital rule? We have to derivative the numerator and denominator unless it becomes a form which is not undefined. Okay. So first we will differentiate this, and t is a variable, so we derivative it with respect to differentiate it with respect to t. So this becomes 10 t to the power 9 fx minus x to the power 10 f dash t by 9 t to the power 8 is equal to 1. Now look at this. If we put t equals to x, then denominator is non-zero, so we can put this limit. Okay. So this becomes just putting t is equal to x to the power 9 fx minus x to the power 10 f dash x by 9 x to the power 8 is equal to 1. Just simplify this. 10x fx minus x square f dash x equals to 9. So this is a linear differential equation. So to say this clearly, just let y is equal to fx. Then what is f dash x? F dash x is dy by dx. Okay. So students, look, we will arrange this in linear differential form. X square dy by dx minus 10yx equals to minus 9. We know that a differential equation is linear of first order and first degree if this is of the form dy by dx equal to py plus q, where p and q are function of x or constant. So in case of this type of linear differential equation, we have to multiply this equation with a factor, and this factor is called integrating factor. And what is the integrating factor? Integrating factor is equal to e to the power integration p dx. This is a chapter of class 12. Okay, differential equation. We will read this chapter. Okay, so now look at these things. This equation till now is in this form. Okay, so to make this in this form, I have to divide this equation both side by x square. So this becomes minus 9 by x square. Okay. So now it becomes a differential equation of linear form, and here p is minus 10 by x. So if is integration e to the power p dx. So integration minus 10 by x dx, and integration of 1 by x is log x. So minus 10 log x. So this with a simple calculation using property of log, we can see that this is x to the power minus 10. So I have to multiply this equation 1 with x to the power minus 10 so that we can get a form totally integrable. Okay. So we are now going to multiply equation 1 with x to the power minus 10. So dy by dx into x to the power minus 10 minus 1 by x means x to the power minus 1, and multiplying with x to the power minus 10 it will become x to the power minus 11. Okay, x to the power minus 11, 10 into x to the power minus 11 y minus 9 x to the power minus 2 and x to the power minus 10 x to the power minus 12. Now students, look at these things. We can write these two parts as d by dx of y x to the power minus 10, that is in the form of u into v, because if we take at the first time, if x to the power minus 10 is a constant, then derivative of y is dy by dx, and secondly we take y as constant and derivative of x to the power minus 10 is minus 10 x to the power minus 11. So we can write this part in the form of uv. Now this left hand side become totally integrable and right side is also integrable. So just if we integrate both sides, we will have our answer. So this is y x to the power minus 10 minus 9. What is the indication of x to the power minus 12? X to the power minus 12 plus 1, that is minus 11 by minus 11 plus c. So y is 9 by 11. Just we have to multiply this with x to the power 10. So this becomes 1 by x c into x to the power 10. Now we will thoroughly check the options. In options A, fx is given as 31 by 11x, which is not true because we already have 9 by 11x, and only 9 by 11x is given in only option B. So our correct option is option B. We need not to check the value of C, because there is only one option where 9 by 11 into 1 by x is provided. So our correct option is option B. Now we will solve another problem. Question number 5, paper 1. Given S is of the form a plus b root 2, where ab is an integer, and t1 is of the form minus 1 plus root 2 to the power n, and t2 1 plus root 2 to the power n belongs to a natural number. Then which of the following options is true? So actually this is a problem not only of set theory. To solve this problem, we have to understand some properties of sequence and some properties of convergence of sequence. Okay, so to solve this problem, first look what is S. S is a set of the numbers which is of the form a plus b root 2, and ab is an integer. So a may be positive, b may be positive, either or a b may both negative, or a b any one of them be 0 or anything else. Okay, so to first, if we take b equals to 0 in S, if we take b is 0, because a b belongs to Z, we can take anything what we want. Okay, and we vary a as in Z, then S become exactly equal to Z. Okay, S become exactly equal to Z. We take in all the cases a b equals to 0, and we vary a, we take a belongs to Z, then S is exactly equal to Z. Then obviously Z is a subset of S. Okay, now we will check what is T1. Actually, the elements of T1 are the sequence of the form root 2 minus 1 to the power n. We take this is as xn. So the elements of this set T1 is of the form. Now, just for simplicity, just we take, if we take n is equal to 3, then what it becomes? Then it becomes root 2 whole cube minus 3 root 2 whole square into 1 plus 3 root 2 into 1 minus 1, that is 2 root 2 minus 6 plus 3 root 2 minus 1, that is minus 7 plus 5 root 2, which is of the form x plus y root 2, that is which is of the form a plus b root 2, and x is a minus 7 and y is plus 5. If we take n to be any natural number, then after simply the binomial expression of root 2 minus 1, we will have either root 2 or multiple root 2. That is, we will have either root 2 or 2 root 2 or 4, either 4 root 2 or 8. That is either 2 or multiples of root 2. And in case of minus 1, we for different n we can have either plus 1 or minus 1. And after just simplification like that, in for any natural number of the elements of T1, we will have the elements of the form a plus b root 2. So genuinely, T1 is also subset of S. And the similar thing holds for T2. Just same, using the same binomial expansion of the elements of T2 for any natural number, all the elements we can easily check the is of the form a plus b root 2. So T2 is also subset of S. So combining these results, Z subset of S, T1 subset of S, T2 subset of S, we can say that Z union T1 union T2 is also subset of S. Okay, so option is true. Now we will check option B, C, and D. Okay, to check option B is given is this is the option B, T1 intersection 0, 1 by 2024 equals to 5. This is option B. Now look, the elements of the set T1 is the sequence of this form root 2 minus 1 2 to the power n. And from basic theory of progression, we know that a sequence r to the power n converges to 0 if modulus of r less than 1, okay, and r to the power n diverges if modulus of r greater than 1. Okay, now look, root 2 minus 1, its modulus always less than 1. So root 2 minus 1 to the power n will converges to 0 as n tends to infinity. Okay, so we can say these from this theory. Now we know that if a sequence xn converges to a limit L, then for any Ps and epsilon greater than 0, we can we have a number, suppose m, such that after this certain term, after this certain time m, all the elements of xn will lie in this interval L minus epsilon, L plus epsilon, for all n greater equals to n. That is, after this certain step, that is after x1, x2, x3, x4, like dot 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 xm. After xm, all the from xm and xm plus 1, xm plus 2, and so on, all the elements of this sequence will lie in this interval when xm converges to L. Okay, this is the fundamental idea of convergency. Now, as we see that this sequence xn converges to 0, so we must have a number k. So after that number k, all the elements of the sequence xk, xk plus 1, xk plus 2 will lie in the neighborhood of 0, because 0 is the limit of the sequence. Now, option B, it is given that 0 t1 intersection 0 comma 1 by 2024 is equal to 5, and this is a clearly this is a contradiction, because this converges to 0 and we take a very small neighborhood around 0, then we can have infinitely many elements of T1 around 0, but it is given that T1 intersection 0 comma 1 by 2024 is equal to 5. This cannot be true. So option B is false. Now for option C, look that we already told you that r to the power n, this sequence will diverges when modulus of r greater than 1. Now 1 plus root 2, this modulus always greater than 1. So 1 plus root 2 to the power n always diverges to infinity as n goes to infinity. Okay. So we will have infinitely many elements. Okay, infinitely many elements in the set from 2024 to infinity. Okay, because it is diverges to infinity. So option C is also true. Now we will check option D. Okay, option D is given for any AB in Z cos pi a plus b root 2 plus I sin pi a plus b root 2 belongs to Z. Now students, look at this thing. Belongs to Z if and only b is equal to 0. Now students, look at these things. This is I is a complex number, so this is of the form a plus ib. So this does not belongs to Z unless this part is equal to 0, because I is multiplied in with that. Okay, so I have to make this sine pi a plus b root to 0. This is the only possibility that this belongs to Z. And since a and b both integer, and we know that for any integer sin pi equal to 0. For any integer n, sin pi is equal to 0. So if we make b is equal to 0, this becomes sin a pi, which is obviously equal to 0 if we take b is equal to 0. Okay, so one part is true, but here is given if and only if. So just taking b is equal to 0, we have to show reversely that if this will becomes to belongs to Z. This is a very simple conclusion. If we take b is equal to 0, then sin a pi 0, then the part involving I will not included here, and cos a pi will be either plus 1 or minus 1. Okay, so this will belongs to Z. So option D is also true. Okay, now we will solve another problem. Problem number 4. This is a problem of ellipse. Given an ellipse x square by 9 plus y square by 4, and PQ is a point on the first quadrant satisfying p square by 9 plus q square by 4 greater than 1, and two tangent is drawn from this point PQ. One tangent meets the ellipse at one end the point of the minor axis, and another to cut the ellipse at touches the ellipse at the point T on fourth quadrant. Okay, and let R be the vertex of the ellipse on the x axis, and O be the center of the ellipse, and the area of the triangle ORT is 3 by 2. Then which of the following is correct? Okay, so students, to solve this problem, we have to first remember some basic properties of ellipse. The ellipse is given is of the form x square by 9 plus y square by 4. Here a is 3 and b is 2, and a square is greater than b square. So its major axis will be x axis and its minor axis will be y axis. Okay. Now, since a is 3, this length OR will be 3. This length OR will be 3. And this length, suppose this is M, OM will be 2. And from S, we draw two tangents. One tangent meets the ellipse at one point on the minor axis, and other meets at the point T on the fourth quadrant. Okay, since it's cuts on the minor axis, it must be parallel to the x-axis. Okay, and since OM is 2, the equation of this tangents must be y equals to 2. First, understand this thing very carefully. This is a tangent. SM is a tangent which touches this ellipse exactly at the on the minor axis. That is, this tangent SM will be parallel to the x-axis. Okay, this is x-axis and this is y-axis. And another tangent cut the ellipse at fourth quadrant, and suppose the coordinate T is x1 comma y1. Okay, and the area of this triangle ORT is given 3 by 2. Since the area of triangle ORT is 3 by 2, we can say half into base into height. What is the base? OR is the base, and suppose LT is the height, is equal to 3 by 2, and since OR is 3, just calculation, LT is minus 1. LT is 1. Since it's opposite to the positive y-axis, its coordinate will be y coordinate will be minus 1. Okay, so we don't know still now x1, but already we have derived what is y1, that will be minus 1. Okay, and since this line is y is equal to 2, q must be 2. So we still don't know what is p, but this is 2. Now students, what will be the equation of ST? The equation of ST will be, since this is an ellipse, x1 by 9 plus y1 by 4 equals to 1. Now we have to determine the value of x1. Since t is a point which lie on this straight line ST as well as on this ellipse, we can put x1 comma minus 1 in equation 1, that is in the ellipse, so that we can get the value of x1. Okay, just now we put the value of x1 and minus 1 in this ellipse. So we have x1 square by 9 plus 1 by 4 is equal to 1. So x1 square by 9 is equal to 1 minus 1 by 4, that is 3 by 4. So x1 square is equal to 27 by 4. So x1 is equal to plus minus 3 root 3 by 2. X1 is plus minus 3 root 3 by 2. And since x1 is on the right side, so it cannot be negative. So x1 must be positive, and the value of x1 is 3 root 2 by 2. Now, actually, PQ is a point of intersection of these two straight lines. Okay. Now, using this theory, we can derive the value of P and Q. Obviously, Q is true, so option C and D is incorrect, because in option C and D, uh, there is uh, uh, Q is equal to 1. Okay. Sorry, here will be 3 root 3 by 2. Here will be 3 root 3 by 2. Okay. Now, uh, we will use the value of x1 in the tangent, so that we can have the value of q. So this is the equation of this tangent st, and uh, suppose this is equation 2, and we will put the values of x, y and x1, y1 in this equation 2, and the value of x1 is 3 root 3 by 2, and value of y1 is minus 1, and what is value of y? To determine the value of p, I have to put y as q. So we take y equals to 2. Just put these values in equation 2. Then we have x into x1 means 3 root 3 by 2, that is 9 into 2, plus